National 5, it is crunch time for you guys. It is the electricity test coming up on Monday. On Monday. So, we need to get through the last bit of work today. I am psyched for you guys. I believe you guys are psyched for this. It is crunch time. Alright? Now, we got to get through the logistics as always. We have 226 subs. It's slowing down, but it's Christmas. I don't mind it slowing down. New Year resolutions are going to be to follow Mr. Bill's physics, so I'm not worried about this. And we know we can get 300 by Christmas. That is just a formality. So we're just putting it up there so you can know it. Now, again, hashtag physics is family. That is the trending hashtag physics is family. Okay? It's just what it is. Now, shout out to one of my National 5 S3 pupils who has managed to get 100% in his waves and radiation test. So, well done to that young man out there. He is going to be an excellent National 5 candidate. Well done to you. Now, we have got lots to get covered in this lesson. Lots to get covered in this lesson. Now, we're going to be doing input and output devices, LEDs, transistors, and switching circuits. Those are the 4 things we are going to do. Now, let's just rattle through this because we have got a lot to cover and not a lot of time to do it. So, an input device. What is an input device? An input device changes some form of energy into an electrical energy. Okay, and I'm going to give you a few examples. Some of them are extremely important. So, microphone. Good example to start with. A microphone changes sound energy to electrical energy. Okay, it has a wee symbol like that, but you all know what a microphone is. You sing into it, and it changes sound energy that we sing or speak, and changes that to electrical energy, into signal. Okay? So that's an example of an input device. Another one is a solar cell. Alright, maybe you have some in your home, but a solar cell changes light energy into electrical energy. Alright, so light comes in and it produces electricity, and that's an input device. A lot more than that on higher. Now, these two are extremely important. The other two, yeah, alright, we know them, it's good. These two are extremely important. Thermistor. You need to know this one, okay? It changes heat energy into electrical energy. Now, don't know why this is not correct, but what happens with a thermistor is a resistor with a line going through it and a T. Alright? Now, why is this important? Because we need to remember one word, and it's a word I think you're going to remember. It's TURD. You need to know about TURDs. Okay? TURD. You need to know this. Why? Because temperature up, resistance down. So in a thermistor, when the temperature of the surrounding environment goes up, the resistance of that resistor actually goes down. Which means the opposite is true. When the temperature goes down, the resistance goes up. Alright? So you need to remember TURDs. Okay, believe it or not, you do. Now, the other one is a light-dependent resistor. So not temperature, but light. And a light-dependent resistor has arrows going into another resistor. And that's what we call an LDR, light-dependent resistor. Now this one is kind of like TURD, but LURD. LURD and TURD. Those are the ones I want you to remember. Because LURD is light up, resistance down. Okay? So when the light goes up in the environment, the resistance of that resistor goes down, or when the light goes down, the resistance goes up. The opposite is also true. Okay? 2 really important ones. We're going to come on to why that's important later. Right, output devices. They change something from electrical energy into some sort of output energy. Now, example, loudspeaker changes electrical into sound. A motor changes electrical into some sort of kinetic, some sort of movement energy. Again, some things that you need to know, but they're not very tricky. A filament lamp, again, something that you'll always see in your exams. You'll see a wee bulb like this, and it has a wee cross going through it, and it obviously takes electrical to light and sometimes heat if it's not very efficient. And then we have LEDs. Now this is the most important one out of the output devices, an LED, a light emitting diode. Now, LEDs are extremely important. They obviously change light, heat, electrical into light energy. Now, this is the symbol, 2 arrows pointing out the way, not in the way, out the way, and a line with a wee triangle. That's the symbol. Why is that important? LEDs can only light in one direction. One direction, that's all they can do. Okay? So you need to put them in the right way round in order for them to light. Otherwise, it will not light at all. Okay? So, let me just talk about some things that are really, really important. So LED do not light when connections to the DC power supply are reversed, i.e. if you change the LED, pop it around the other way, it's not going to work. It needs to be the right way around, and I'm going to show you what that is in a circuit just shortly. LEDs only require a small amount of current to operate it. So you'll often see LEDs are accompanied with a resistor, because the resistor is there to protect the LED from having too much current flow through it. So it's to protect the LED from too high a current going through it. Okay, so it's always accompanied by a resistor. LEDs do not get hot in operation, they're very efficient, and are used in hi-fis and instrument panels. Okay, lots of things use them. Your phone uses them, for goodness sake. Now, let's do a wee example. This is what I mean, though, first of all, that LEDs need to be the right way around. You will only get an LED lighting if the arrow, or if the line here matches the small line of the battery, which is the negative. So that line there needs to go towards the negative, okay, or the small line of a battery. So large line on the LED, move it round, doesn't match the negative or the small line of the battery. That is extremely important. Always remember that. You get tons of questions. If I was to have another LED the opposite way around here, the whole thing wouldn't work, because it's almost like you've got a gap in the circuit, because it's not going to work. Alright? So it needs to be that direction. Alright? It needs to be. Now, let's look at this question. What is the purpose of the resistor in the circuit below? Well, I'm not going to write it because I just said it. It's to protect the LED from too high a current. To protect the LED from too high a current. Alright, so that's what you need to say. Too high a current will cause the LED to blow, so you need to make sure that you have a resistor to protect it from too high a current. Calculate the value of the series resistor. Now let's do this one on the board. So, what I need to do is I need to find out the resistance, the voltage across the resistor. It's a series circuit, so every voltage must add up to the supply, as we've been learning. Okay, so I'm just going to do it up here. So VR equals VS minus VLED. Okay, so 5 minus 2.3 gives me 2.7 volts. 2.7 volts. And then all we do is V equals IR. So R equals V over I equals 2.7 divided by 0.01, 10 milliamps, gives me 270 ohms. Okay? 270 ohms. As easy as that. Those are the kind of questions you get. They're 4 marks worth. Get it right. You can get it right. National 5. Right. Now, other devices that are important are relays. Let me just get my room and my pen. Here we go. Are relays. Relays are extremely important. You'll see them a lot. They're basically electronic switches. Okay? So when current passes through, and a correct current, what happens is the switch closes in another circuit. So that switches another circuit, and it manages to close it. So therefore close this switch. So then the circuit turns on. Okay? So it's basically just a switch. All right? But it uses magnetism in order to open and close the switch. Okay? And then we have a capacitor. And capacitors just store charge. Okay? Remember Q equals IT, charge? They store charge. Okay? Now, capacitor charges, the voltage across it increases until it reaches the voltage supply. So actually it takes out all the charge until it reaches the supply voltage, and then everything in the circuit stops working because it's balancing out. Alright, so it's 6 volts voltage supply. The capacitor, when it's charging, will take up all of that until it gets to 6 volts, and then it'll stop. Okay? And the current in the circuit decreases to 0 when that happens, because if you have 6 volts and 6 volts, there's no movement of the charge. So therefore there's no current. Alright? So you might see them, that's just a wee addition. Make sure that you know where they are. Alright? Now, transistors. So we're racing through this. This is 3 out of 4. There's 2 transistors you need to know. One, NPN transistor. This one comes up a lot. In an NPN transistor, you have 3 things. You have the base, you have the collector, and you have the emitter. Now, NPN transistor turns on at around about 0.7 volts. So when there's a 0.7 voltage across here, then the whole switch turns on and it allows electricity or current to flow from what we call 2 rails. The top rail down to the bottom rail. And we're going to show lots of examples of that in a second. Okay? So, for example, this would be a NPN transistor here, and if there's a big enough voltage across this bit here, that will turn on and it will allow the LED to light. Okay? Now, MOSFET is another fancier transistor, which actually stands for metal oxide semiconductor field effect transistor that no one ever needs to know, so don't worry about it. But this is the diagram here. Okay? So you have the gate, the drain, and the source. Alright? And this one opens up at 2 volts. When it's 2 volts, that one can open and it causes electricity to move through. Alright? Now, that's transistors. You just need to know that they're basically glorified switches that turn on depending on the voltage across them. Alright? Now we've got some simple transisting circuits to get through. This is the last bit of the electricity topic. That's it. It's the last bit. Alright, so let's see if we can get going with this. Right, a light controlled circuit. Remember back to LDRs that I said about in the input devices? We need to remember those now because we're going to look at that and see how that affects a real-time circuit. Okay? So circuit 1. Explain how the following circuit works to switch on the LED when it is dark. Okay? So when it's dark, the resistor, remember, light up, resistance down. So if it's dark, light down, resistance up. Alright? So if the resistance is up here, the voltage is actually up as well. Because remember, large resistance is large voltage. So voltage is up. If voltage goes up here, then that means that the voltage across here is going to turn this on, which is going to turn the LED on. Okay? So actually this is like a street lamp. When it gets dark, somehow the light turns on. Okay? So how would we write that? LED is off. This is how you do an answer. 3 marks. How you do an answer. LED is off. As light goes down, the resistance of the LDR goes up. Then the voltage of the LDR goes up. It's greater than 0.7 volts. So therefore the transistor switches on, and therefore the LED switches on. Okay? For time I'm going to move on, but if you need to pause that, look at that. Pause it, look at it. Okay? Because now we have another circuit. And in this one, it's asking us to explain how the circuit switches on the motor when it is light. Notice that the LDR has now moved up to the top. This is the second type of circuit that we get. So in this one, let's just go through it now. The motor's off. As light goes up, light up, resistance down. Resistance goes down. Therefore the voltage goes down. If the voltage goes down here, the voltage must go up here. Why? Because everything must add up to 5 volts. So if you get a lower voltage here, this must add up to get to 5. It needs to happen. Okay? Then that means if the voltage is great here, it turns on the NPN transistor, and therefore the motor turns on. So for an example, this would be like if it was too light and you need blinds to come down. This would be what the circuit you'd use. The last one, temperature controlled circuit. Explain how the following circuit works to switch on the bulb when it is too hot. Okay? So it's too hot, like for example in a fridge, when it's getting too hot, if there's a light turns on that it's too hot, you need to close the fridge door. So let's have a look. Bulb is off. As the temperature goes up, TURD, temperature up, resistance down. The resistance of this goes down. That means the voltage across this goes down. But remember, it needs to add up to 5, so that means this must go up. Okay? It's greater than 0.7 volts now. Transistor switches on, which means the bulb switches on. Alright? There's so many examples of these circuits. Pause it, go back, pause it, see if you understand it, and see if it makes sense. Okay? Now, that's electricity done. We've done it. 8 weeks of electricity. The Christmas holidays are so close. We have done it. All the best, National 5, for your electricity test and for the prelims. You have done fantastically well, and I am so proud of every single one of those who are listening and viewing. National 5, it has been a joy, and I'll see you again some point soon. See you later, National 5.